Hey, welcome everyone. I really hope you're enjoying your time watching all your MCTM videos. I'm super excited to share this with people. I'm always amazed at how excited people are at the end of one of these sessions about the thinking classroom. And I think a big part of it is because it's just refreshing. It's a refreshing way to look at teaching. It's a refreshing way to teach. And it's something that I'll never walk away from. And so today I'm going to talk to you about the thinking classroom. It's originally designed and researched and everything by a professor in Canada named Peter Liljedahl. You can follow him on Twitter and check things out. He has a book. I'm going to share it with you about the thinking classroom. It'll tell you way much more than I can tell you. You'll see the bit.ly there that I have. So the bit.ly is going to get you to this exact slideshow that I'm going to show you, because I have tons of links in here for you to use. And I want you to be able to follow them. I'll have a couple of videos in here. So please, please copy this down, get this into one of your windows so that you have it for later. And my name is Jessica Strum. I'm a mathematics teacher, and I'm also currently the MCTM High School VP. My email's there and my Twitter handle. Please feel free at any time to connect with me, because this is one of my most favorite things to do besides teach, is to talk to other people about teaching math. So please feel free to contact me at any time. So a little bit about myself. This is my family here on the right, the Strums, one Halloween that we got dressed up for. And I teach in a small little school in northwestern Minnesota. It's called the Winnimac School District. Winnimac comes from the towns Winger, Erskine, and McIntosh put together when they consolidated. I actually grew up down the road from here, about 7 miles away, at what would be considered a rival school, but they've welcomed me in, and I've been here longer than they're at this point. This is actually my 18th year of teaching, and I live in the town of McIntosh. A little bit about my classes. I teach Algebra 1, Algebra 2, College Algebra Trigonometry, and Tech Math. I don't teach too many middle schools, but you know, the really cool thing about the thinking classroom is it actually works for any grade level, K through 12. So before I get going, I always like to start off with asking people, what would your perfect class look like? So just take a moment right now and think about this. You walk in, or maybe you're in the middle of teaching and all of a sudden you just pause for a second and you just look around you and you listen. And what would that perfect class look like? What would the kids be doing? What would it sound like? What would you be doing? Now, we're not live, so I can't really ask you to respond to me. Maybe you want to go in the chat window, and other people who are watching this can go in the chat window and you'll be able to see the answers that other people are coming up with. But most of the time when I ask people this, they are talking about the kids talking, the kids being curious, the kids wanting to know more, the kids asking curiosity questions. And it really stems a lot on what are the kids doing and how are the kids interacting. And the teacher's role a lot of times is just kind of sitting back and enjoying it. And, you know, when I started doing the thinking classroom, that first year, and even now, I'll stop sometimes and just like observe my class, and I'm going, oh my gosh, I have exactly what people are saying that they want for the perfect class to be like. It's just amazing. And so the other thing that's amazing about it is just how easy it is to get that to happen, to get kids to be involved in doing that. It's really not difficult. So here's the deal. I came about this on my own, kind of independently, because I was super frustrated, right? Post MCA season. I mean, when you're watching this, you're probably in the middle of it or just finishing up your MCA season, right? And as I was, you know, like looking at what the test prep was, and I would give kids like a test prep question like this maybe. And I would look at it and go, my kids can do this. We've done this math. My kids are ready. They can do this. And too many of them were kind of what you see down there on the right? Only 39% of students. This is one of the released items. And so this is the MCA data that says 39% of the students selected the correct answer. Like, that's so frustrating to me, because really they have the skills, even if they don't know how to come up with the equation themselves. It's multiple choice. They have the skills to do this. They have the skills to figure it out. And yet I'm seeing the data on the right. Like, this data is what I'm seeing. And I'm so frustrated by it. I'm so frustrated. We worked so hard. And so I'm looking through these, and I'm looking at the data here. Let me move my picture out of the way so you can see the data. I'm looking at it, and I'm looking at just frustration, right? Frustration. And so I remember I was walking along I was going for a walk one summer and I was just frustrated about this. And I was thinking to myself, I've got to get my kids better. I've got to get them to be more active mathematicians. I've got to get them doing stuff. Okay. And so I got to get them so that they can do these problems. So I was just listening to a podcast called Making Math Moments That Matter. And they were interviewing a man named Peter Liljedahl. And he was talking about this exact thing, how kids are not problem solvers and how can you get them to be problem solvers. And so that's where I started my little journey on figuring out what the thinking classroom was. So here is what do they call this? A sketch note. This is a sketch note made by Laura Wheeler about something that Peter Liljedahl did. And here's what I'm so impressed by him is it's not just like, he doesn't just sit here and say, okay, I've been trying this for the last 3 years and this is what's working. He actually went out and did full on research with this. And I'm going to share his research results with you. But like, he didn't just do it quietly. Like he tried so many different things. If you ever listen to him, he tried so many different things and proved over and over again the things that he says works. And so I thought this was a really interesting sketch note. And this is talking about what studenting is. So he talks about studenting as being how the students game the system. So how they figure out what is their job as a student to do and how to do it in the way that they want. And if you were in my room right now and we had the time to do this, I would tell you to take some time to notice wonder here. You're watching a recorded thing. So you know what? I would really love it if you would pause and take time to really get to know what the sketch note is saying. So hopefully you did that. And so let's talk about this. So you and I all know that this is the typical math classroom. And let's all be honest, this is my math classroom, right? So what I do is I give direct instruction. Okay, we're solving equations. I'm going to show you how that you add or subtract to get that constant to the other side. And then I'm going to work it out. And now I'm going to give you to try one. And then I go over it. And then I give you to try one. And I go over it and I give you to try one. And we'll do that all hour long. And what is going on with our students? What is the studenting game here? He found in his research, so they actually recorded and counted and did all these things, that half of the students were mimicking. So they were just copying the exact steps you did. And what happens is when we give them a different one, let's say I give them one with a decimal in it, which you're like, they can do decimals, right? That shouldn't be a problem. And how many times do you have a student go, oh, I can't do this. You just made it much more worse. And you're like, it's the same steps. But because they're mimicking, as soon as you change one little thing, they feel like they can't mimic anymore because it's not exactly what they've been watching you do. Okay, so they're finding about half of them are mimicking. You know, they're honestly trying. It's not that they're not trying. It's just, that's just part of the game. Okay, we have the ones who fake it, right? So in the orange here, they're faking, they're pretending to do the problem. And they're just waiting for the teacher to go up there because they know the teacher eventually is going to show them how to do it. So if they can fake their way through it and make it look like they're doing math, when you walk by, you're like, oh yeah, they're still trying, they're still working on it. Really what they're doing is they're just waiting for you, okay? We have in red the stalling kids, right? This is the kid that needs a pencil. I can't find a piece of paper. Can I go to the bathroom? Something's under my chair. I need to look at it, right? These are the kids that stall until you get tired of waiting for them and get going on showing them. You have the ones who just aren't even hiding it. They're just going to sit there and not do it at all. They don't care. And then you have the group that you want. You have the ones who are actually going through and reasoning and thinking beyond what you're asking them to do. And you know, they're doing what it is that you want all of your kids to be doing, right? And so when I saw this, it's kind of a slap in the face actually, and it's really kind of hard pill to swallow. But if you're going to be super honest with yourself, this is what's going on in classrooms. And this is where I'm frustrated, right? So I'm looking back at what my kids were doing and I'm like, yeah, this is what they're doing. So obviously when they get to that MCA question, if it doesn't look and smell and sound like the question that I gave them and they can't mimic their way through it, they don't really have the skills then to do this problem. Okay. So just my green ones here have those skills. So I need to change this. I need to change it. And what's super exciting is that the thinking classroom totally changes this. Now on the left is homework. We're not going to get into that right now. I'm going to talk about that a little bit. If you go to my live session, we're going to talk a little bit about homework and what all that says on the left. But right now I want to talk more about what's happening in the classroom. I thought this was an interesting tweet from Alice Keeler a couple of years ago. about her aunt was frustrated because the kids that are coming into the workforce now don't know what to do on their own. They can't figure out the next step on their own because they're being told all the time in class what to do next. Get out a pencil, get out a piece of paper, write this problem down. Now do this, now do that. And so we're training these kids to be kind of helpless in a way and not be able to figure out stuff on their own. And so I need to change that, right? What am I going to do? And so when I was on that walk and I was really frustrated about it, and I was listening to Peter Lilladell on this podcast, I realized that I need to get my kids to think. That is my goal. I need my kids to think. So how am I going to do that? So if you've ever heard Sarah Vanderwerf talk, she talks about what is a mathematician, right? A mathematician notices, describes, and generalizes patterns. And I love this description of mathematicians. I spent a lot of time at the beginning of the year talking about it. If you read the book by Jeff Kroll called Necessary Conditions, you're also going to see this definition of what mathematicians do, right? They persist through challenging problems. They don't quit. They communicate their ideas. They can write down their steps and show people what they're doing, and they can do that cleanly. Okay. They don't always get the answer, and they're okay with that. They're creative. They're not just mimicking someone else's steps. They can come up with their own approaches, right? They can try other approaches, not just one. They can work together and encourage each other. They can see the beauty in what they're doing, and they can find meaning in their work. And this is what I want my students. Okay, I want my students to be this mathematician, not the mimicker, not the person that graduates and says, oh, I hate math. I want them to see the beauty in what they're doing and to be able to do this, because this is what's going to translate in the world, right? When people say, when am I ever going to use this math? One of our most common answers as math teachers is because I want you to be a problem solver and I want you to be able to go out in the world and be able to problem solve. But if all they're doing is mimicking me, then they're not going to be a problem solver. I need to train them to be a problem solver, and just giving them math problems isn't making them a problem solver. So enter the thinking classroom, and that's what I'm going to share with you right now. It's going to be the basic structure of the thinking classroom, not everything, because you can't do it all in 1 hour. I'm also going to put out there, I am not the professional here. I'm just sharing what I've learned, what I know at this point, and what has happened in my classroom. But I still have a lot of learning to do, and I am definitely working on that myself. So this is an introductory course to the thinking classroom. Here's one thing that struck me about the thinking classroom. You know, we've all seen this. I saw this when I was in college learning to be a teacher, right? They showed me this thing about equality is they all have the same size box. Equity would be that we give them a box the right size so they can actually see the game. There's also some criticisms of this. One of them is they're watching the game and they're not in the game. I don't want my students to watch me do math. I want my students to do the math. And then there's also like, this still doesn't make me feel like it's my classroom, and this still doesn't make me excited about teaching. So I came across this other one by Kate Novak, and I got her permission to use this. And so it's kind of the same idea. The equality one first, where the kid can't see over the counter, the other girl can kind of see, they're all on the same size stool, right? Okay, the next one, okay, they have different size stools, so now they all have the same visual of the teacher doing all of the cooking. But once again, they're not involved. This one here, when I saw this, I got the goosebumps, because this is the feeling I have in my classroom every day now. My kids are doing the cooking. I'm walking around, I'm critiquing, I'm helping, I'm pushing, but my kids are the ones doing it, and they're doing it in a way that they're all where they belong, right? We have the short little table for this little guy here. We have a stool and a table for the girl who wants to sit at the table. We have the other one standing up at the teacher's thing, which, by the way, is no longer the teacher's thing. It's now that girl's workstation, right? And there's so many things here that speak thinking classroom to me that I just love this picture. So what does it look like in real life? This is my classroom. Don't worry, this is a couple of years ago, pre-COVID times. So don't mind my mess. Actually, they talk about how the thinking classroom is best done in a messy room. So I'm so excited about that, because my room's never spotless and tidy. But this is what it looks like. These are what my kids are doing. You're going to see a lot of things. You're going to see my kids working. You're going to see them talking. You're going to see kids looking at other boards. You're going to see all kinds of stuff, thinking, discussing things. You're going to see messiness on the board. You're going to see that maybe some groups are done and they're working on something else. Some groups are still working. Here you're going to see sometimes you have ones where all the kids are writing, and sometimes you have where one is and the other ones are talking to them. Okay, these kids got a little tired and decided to sit down. I usually discourage that, but hey, you know, sometimes that's what you got to get done, right? I want to show you another classroom. So this is a classroom in live. It's going to be 30 seconds and it's fast forwarded. Okay, so while you're watching this, I want you to take a mental note of what are the things that you notice. So this is the entire class hour. There's no sound to it. This is the entire class hour in fast forward. Kind of makes me jealous right now that they don't have to wear masks, right? This is an old video. Okay, I'm going to play that again, and I'm going to talk about the things people tell me that they notice. Okay, so they notice this girl standing in the middle. That girl is actually just an observer. She's not the teacher. What you're going to see is this guy, if you've seen him, he's bald in a black shirt. He's walking around. He's the teacher. Okay, you catch glimpses of him in different places. You see kids moving around. You see kids going to their desks to grab things. You see kids going from group to group. Eventually here, you're going to see the whole class gather and be like looking, and they're going to be actually, it's a classroom right here. So he's talking, he's teaching the whole class at one time about something. And then you're going to see them go back to their groups. Notice how nobody's sitting around. Nobody's not on task. They're all very active. And so that is what the thinking classroom looks like. That is what my class looks like, with very little classroom management. So what Peter Liljedahl has done is he's put 14 characteristics together, or what does he call it? 14 practices, teaching practices that make up the thinking classroom. You don't have to do all 14 to make a thinking classroom, but they're all part of what you should be doing. And he's grouped it. You'll see I have year 1, year 2, year 3, year 4. He's grouped it so that you don't have to try and do all 14 at once. I started out with the first 3, year 1, and I said, okay, I'm going to get really good at these things, and I'm going to start dabbling in the other years and go forward. So this session right now is going to mainly focus on year 1 and what are you doing? Because those 3 things are necessary for you to have a thinking classroom. So year 1 has 3 things. You need to have good tasks. You need to form what they call visibly random groups. And you need to use vertical non-permanent surfaces. So I'm going to go in depth on all 3 of these things. So we're going to start with the vertical non-permanent surfaces. We all call them whiteboards, right? But not everybody has enough whiteboards. I'm in my classroom right now. You can see I have whiteboards. I actually have whiteboards on 3 of the 4 walls. I have tons of whiteboards. My school is super generous. When I said I want whiteboards, they said, okay, so they got me whiteboards. But you don't have to have whiteboards. And the reason they don't call them that is because you can do all kinds of stuff. You can have chalkboards. You can use windows. I've tried taking out like shower curtains and putting them on the wall. I've gone to Home Depot and I got the shower boards. They have like 8 foot by 4 foot shower boards. And I had them cut them down to a smaller size. For example, I'm in my room. I might as well get them out, right? So I have them cut into these smaller sizes for my kids to use. I actually sent these home during distance learning so that my kids could use them behind them and actually write on the board and talk in their breakout rooms. Okay. And those work super nice. And I've seen teachers just take those and drill them into the wall and have them on the wall. So it doesn't have to be these expensive official whiteboards. It could be just about anything. So instead of calling them whiteboards, he called them vertical non-permanent surfaces. It's really important though. It's something you can just wipe off with your hand. It can't be a piece of paper. It needs to be something that's just really quickly wipeable. Okay. And so what he found in his research, and I told you he did tons of research. He tried out whiteboards that are flat on the table. He tried out paper, vertical on the wall. He tried it all. And what he found was the whiteboards brought kids to writing faster. So, you know, you send the kids to the boards and you say, okay, get going. The whiteboards had the kids writing on the board right away, whereas other ones took time. And part of that he found was because they're more willing to make a mistake because it's super easy just to wipe off. Okay. By having it vertical, kids are standing up. When you are standing up, you can't hide as well. And not that kids are out in front and part of everybody's watching them, but you can't, you just kind of mentally don't feel like you're hiding as well as if you were sitting at a table in a group. So when they are standing, they're more likely to participate. They're also, when they're writing, you know, when we have lined paper, it really forces the kids to stay in a line. Well, thinking is not linear. And so it's really nice that they have the space to be able to write wherever, and kids can add things in different spots and they can keep track of things. And then the other super cool thing, and I didn't realize how cool it was till I really started dabbling with it, is the mobility of knowledge. So the idea is, if I'm over here in a group over here and I'm talking to them about something, a group over there might be kind of eavesdropping and watching. And what happens is they see that and they get an idea and they start doing something with it because they were stuck originally. And that's a cool thing. That's not cheating. It's getting an idea. Kids are not copying. If you listen to him talk about all the research that he did, kids were not copying it. They were just getting an idea and going from there. And it was super cool. And kids moved farther and they understood way more by having that ability to see what was going on across the room. If they're flat on the table, they don't see what anybody else is doing and they get stuck and they can't go forward. And so I become less important for every group, because now they can start working off of each other's work and move forward and not be waiting for me all the time. So this is super cool. Now, one of the things that I tell the kids to do, you'll see this group right here. This kid is with one marker and the other ones are standing off to the side. That is actually super important for the groups to be working together. You know, you have that one kid in a group who will just take the marker and start working, and the other two will just kind of stand by and watch. That's not cool. Okay, that means that they're not actively involved. So what I do is I give them one marker and I say, okay, whoever's writing is not deciding what to write. So if I want you to write something, I have to tell you what to write. I can't take the marker and write it myself. So if you have an idea and you're holding the marker, you got to hand it off to someone else and you've got to tell them what to write. It super, super helps with everybody being actively involved and having to discuss. And it's super cool too that they have to explain themselves to someone else in order to get them to write it. Now, this is the actual research that he did. So you can see right here, like time to task, vertical whiteboard is 12.8 seconds. 13.2 for horizontal whiteboard, vertical paper. So it's, what they're talking about is just like the vertical part of it, they get talking about the task more quickly than they do on the table, but it's not by too much, right? So it's like, you know, 1 second, is it really that big of a deal? But look at this, time to first notation, 20.3 seconds with a vertical whiteboard. Horizontal is just a couple more seconds, but look what happens when you get more permanent, right? It is minutes before they start writing something down. And sometimes don't you go to a group and be like, just try something, please? And they're more willing to be brave if they're on something that they can wipe off real easily. Eagerness. Okay, eagerness, they rated it, I think, from like a 1 to 4. I have that on a later slide, or maybe it's a 1 to 3. How eager were they to do this a task? And when it was a vertical whiteboard, you can see the eagerness is quite a bit higher. I think 3 might be perfect. So they're eager, and you'll find that, you know, if I give kids a homework assignment and tell them to do it in their paper, it's drudgery, right? But if I put them on a whiteboard, it's like, hey, let's do this, let's get this done. So it's really a big deal. And you can read through this yourself. And it's one of the reasons I want you to have this document, is so that you can like really look into it and see what it all means. After this, I also put in more of there's a link to the actual research, and then it just kind of explains the, you know, the score from 0 to 3, you can see that, and just how do they rate these things and how do they come up with this rating system. So I'm not going to spend my time going through this. You can go through and read it and see it for yourself if you want to look into that more. But that's talking about having a vertical non-permanent surface. The second thing that is super important for this is that you have visibly random groups. So let's talk about what that means, because this is also kind of foreign to us. I was taught you can group kids based on abilities, right? You can put all your, I'm going to quotation this, okay? You can put all your high kids together and all your low kids together, or you can have a heterogeneous group where you have high and low mixed. This is saying, no, we're not going to do any of that. Okay, there's all kinds of reasons for it. But what we're going to do instead is we're going to do visibly random groups. Visibly meaning the kids see you do it. Okay, not that you come to class and say, here you go, guys, I separated you into groups, because they won't believe you that it's random unless you do it visibly in front of them. So what I do is I have a set of cards here. I have my little book that I keep my cards in. I have a set of cards and I shuffle them up. I figure out which ones I need. I shuffle them up, and then they see me pull out the card. They see it be random. They see me shuffle it. They're obviously not random right now. They haven't shuffled them, but and I hand them out and I tell them where to go. And then you'll see that like on my whiteboards, let's see if I can get a picture of this. On my whiteboards, I have a card on there. So I have an ace here. So then if a kid gets an ace, they know that this is the board they go to. It saves a lot of time of telling kids, they'd know where to go. And then they go to that board, and it's totally random. And there's all kinds of ways you can argue this. And I know that I was uncomfortable at some things. There's all kinds of social issues that you might be worried about. You might be worried about, you know, some kids getting put together and not being motivated to move forward or not knowing how to move forward. Let it go. Okay, so he did the research. He did so much research on this. And I'm going to tell you, you need to listen to some of his podcasts that he's talked about, because he talks about how he would have a very diverse group of kids who had a bit of clashing going on. And by, I think he said week 6, he would walk into the cafeteria and those groups were intermingled at lunch because of what they found out in class, because they learned that each other is a human being and has a story, and they have connections and they have common things. And so, so there's very few times that I do not let it be random. I've had like very few times that I've had 2 students that maybe the day before got into a physical fight in the hallway or something. And so then I make sure that they're not in a group together, but otherwise it's random. And I have kids that really don't want to be with other kids, and they let me know that. And I tell them it's okay, you can handle this for right now, because I'm going to do it often. I do it every day. It's a different group every day. So they're not stuck with that person for the quarter or the week or anything like that. It's different all the times. Okay. So, and then also the groups of 3. And I know this is difficult. I am lucky to teach in a school where I have very small class sizes. My biggest class this year is 16. So I'm super lucky that I can easily do that. But if you have a class size in the 30s, a group of 3 is kind of difficult, but I still highly recommend 3. You know, in his research, he showed that that's really ideal. If I can't do 3, so sometimes I don't have multiples of 3 in my room, then I do groups of 2, as few of them as I need to, but I don't go up to 4, because 4, you tend to have someone left out. I try not to do 2 also, because 2 makes it kind of awkward, especially if the kids don't get together. That third one is kind of a little bit of a buffer there. But I do it every day. I get different ones all the time. And you can see that I kind of talked about a bunch of this stuff already in this sketch note. The mobility of knowledge between students goes up. So what happens is kids start getting to know each other better. It's not always working with their best friend. It's not always working with the same kids because you're all at the same level. You get to know other kids. And what's also super cool is they start seeing that there are kids in their class they didn't think had anything to offer. All of a sudden, those kids have something to offer. They had a good idea that got the group going, things like that. So, some of that power struggle of who knows more kind of goes away when they are in groups and are problem solving together. The other thing that happens, they rely on me a lot less, which is super cool. And there's ways to make that happen more than it just happening on its own. But being in these random groups helps. Let's see, they get to know each other better. You can read it for yourself here. So this is Visibly random groups, super important. I do not skip this. I do not be like, hey, go match up with your friend. The other thing that I really like too is it takes away the anxiety. I'm a super introverted person. And when it's like, okay, everybody find a group, that was a horrible time for me in class. I did not like that. That was not cool. So if you were just telling me to go to this board and I'm grouped with whoever's there, that's way more comfortable for me. So just remember that not everybody's comfortable finding their friend. They might not have a friend, or that friendship might not be reciprocated the same way, and all of a sudden that friend's with other people. And so they're left out and very uncomfortable. So this is a really awesome way to be able to do this. All right, and again, the research, and we've already talked about these things that are listed here, but I wanted to make sure you had the chance to look at the research yourself. Okay. So the third thing is a good task. Now this I personally think is one of the most difficult things because I want someone to hand me the curriculum with all the tasks, right? So there's some curriculums that do that. CPM has some really good tasks that you can take, things like that. Now, when Peter started doing his research, if 6 cats can kill 6 rats in 6 minutes, how many cats are required to kill 100 rats in 50 minutes? This is kind of his go-to problem, that if he was entering a class to give him problem solving, he would go with this one. So this has a lot of really good stuff to do with rates, and if it's applicable to your curriculum, is an awesome task. Where can you find more like this that are applicable to your task? An example is a website called Enrich, and this is one I found on probability. And you can read through it yourself, but this would be a great one to give if you're working on probability. So the idea is what's really rich task that has to do with your curriculum. And so I like going to Enrich to find them, but there's lots of places that you can find things and start collecting them. Okay, now this is always what people think of though, is this rich task like this that has a low floor, high ceiling, is related to your curriculum, and you know, they're not always out there for you, or you're not finding the one that you want that's going to do what you want. So what other kind of tasks can you do? And this is where I spend most of my time, is on the others. So one of the examples is a progression from the known to the unknown. So what Peter Liljedahl calls this is thin slicing. So thin slicing is you start with a problem that they know, and then you build onto it and build onto it and give them another one and give them another one. And you tweak it just enough that it's a little bit different than the last one, but it's progressing them into what you want them to be able to do. So one of my favorite ones, I'm just going to share an example. This is a high school example, but I think if you're an elementary teacher, you're going to be able to follow along with this one just fine. So it's super important, you know, in the elementary that they start doing area models to show multiplication, because as high school teachers, hopefully are using them when we get into our polynomial operations. So I always start in this lesson. I start talking about, hey, in third grade, you learned about arrays. So 3 times 4 was an array with 3 by 4. And then you start building it into, maybe I'm not going to draw all of the lines, all the boxes. I'm just going to empty it out. And I'm going to say, okay, I'm going to have this rectangle. I'm going to put 3 here. And then I'm going to break up 12 to be a 10 and a 2 and figure out how does that give me this multiplication. And then I'm going to make it even more complicated. I'm going to do 35 times 23. And I'm going to give these to my kids. So a lot of times if I'm doing like, this is how I teach, you know, my multiplying 2 binomials. I go through this with them, and maybe I give them this one on the right here as a notice wonder. What do you notice about this? Because a lot of kids have either A, not seen it, or B, have forgotten about it. So I need to get them more familiar with it. So we go through this progression here, and we look at that. So then I still got this one, and then I say, okay, now I'm going to show you this one. And so this one, it's showing the 2 binomials being multiplied. Instead of teaching FOIL, I'm using the area model. And they figure it out for themselves. They do a notice wonder. And then I might show them this one to show that you can have more than 2 terms and you can still do the multiplying and it works out just fine. Okay, but here's my lesson plan. Sorry, I know it's really technical lesson plan. This is kind of how I go though. So what I do then, now I'm going to get them to the boards. I've gotten to groups, and I carry this piece of paper. This piece of paper walks around with me. And I go to the board and I write down the x squared plus 9x plus 18. And then I give them this box and I tell them I want them to fill in the blank spots. So this spot right here and these 2 spots right here. So it's their job to kind of solve the puzzle, right? And so I go around and I give the groups this one, and then I come around again. And if they're good and they're done, then I give them this one. So I give them this quadratic, and then I give them this box with the blank spaces. And then I progress into like slowly taking away things. Now I'm not going to give them the X's on the outside. And then I'm going to do another one, change around, mess around with the negatives and how do those work, and not give the X's on the outside. Then I'm going to give them one where I do the X's, but there's no BX term here, right? There's no single X term. And then I'm going to give them one, and I'm not even going to give them the box. Sometimes I don't even draw the box because I'm like, here you go. What are they? And here's what happens. They know how to factor it into 2 binomials without me telling them a single thing. Because I've gone through this progression and they keep on going through this progression, I don't have to tell them a single thing. They figure it out for themselves. So this is one of my favorite ways of using the thinking classroom, is to do a thin slicing progression. Another one that I really like doing is that I pose the goal for the day and let them figure it out at the boards. So here's one of my favorites. This came out of nowhere. I was just like, this lesson originally, before I was doing Thinking Classroom, I hated this lesson. And so I started changing. I just thought, why not try something else? So here's what I did. I gave them this and I gave them a notice wonder. My goal for the day is to get them to be able to take something in slope-intercept form and turn it into standard form. They know all about slope-intercept form. They know about the y-intercept, the slope, all that stuff. they haven't learned about standard form at all yet. Like I haven't officially said anything about it. So I give them this notice wonder. Okay. And they do a notice wonder. They notice all the different like fraction, not fraction, X and Y on the same side, you know, all this stuff. The two bottom ones are the same, but opposite signs. They notice all that stuff. Then I tell them to graph all three on Desmos. What did they notice? They come to notice that all three are the exact same line. So then I tell them, okay, here's what I want you to do. I want you to take the standard, this slope intercept form, and I want you to do math. That's what I call it, do math until you get a standard form, until you get one of these. I don't tell them anything about how. They know how to solve equations, you know, but I don't tell them how to do this. They struggle a little bit, but they do. They go, they work on it. And one of the things that I like to do, and I had to do during this one, was they would get stuck, and the kids would do things but just not get there. And so one of the things I like to do, a little teacher move here, is I will call out, I need one person from each group to come to me. The rest of you keep working. And I thought I was going to have to really manage this one, but it really worked out really smoothly. So one person from each group came to me. I wrote this one on the board, this top one, and I said, what have you guys tried? And, or maybe the first question is, what is it that you want to do? And so they'll tell me, well, I want to get rid of the fraction and I want to get X on the other side. So I'll say, okay, what have you guys tried? And so they'll start talking to me. Now, the first year I did this, they totally, one group told me that they moved the 4/3 X over by subtracting it over. So I showed it, and there was other groups going, oh, I know what to do. But then we weren't done yet, because those, you know, the group that moved it over didn't know how to get rid of the fraction. And so I talked to other ones, and either they knew how to do that, or we came up with ideas. So we talked about, well, what is it that makes, so my goal, by the way, is not to tell them anything, is just to ask questions to lead them to it. So what is it that makes it a fraction? How can we get rid of it? You know, what can we do? So I'm working with just a little group of one from each group, and we work it out until they feel like they're ready to go and they know what to do. And then they go back to their groups, who, by the way, kept working amazingly without me having to even pay attention to them. They kept trying it. They wanted to figure it out. They go back to their groups and they're like, hey guys, this is what we do. And so then now they have to retell it to their group, work it out. If they're still stuck, they can tell them usually enough to get the group going, and then they figure it out. And then what I'll do is I'm going to do this thin slicing again. I'm going to give them a new problem, a new one that's in slope intercept form. They work it out. They figure out in standard form. Mrs. Strum, is this right? And I said, I don't know. How could you check to see if it's right without me telling you? They go back to Desmos. They're like, oh, I could plug it in a Desmos and see if they line up on the same one. It's really great for them to really make that connection. I want them to make that connection between the math that they're doing on the board and the graph that they're getting. So they use Desmos. Then maybe the next problem, instead of giving them the equation, what I've done is I've given them a slope and a point. And so then they have to put it in slope intercept form and then change it to standard form. And it's a lot of fun, because they're like, I don't know how to put a slope and a point into standard form. I'm like, well, do you know how to do it with anything? And they're like, well, I know how to do it with slope intercept form. I'm like, oh, okay. And then I walk away, because there's really no need for me to keep talking to them. This is a really fun lesson that I've done. And then if they get to it, which not a lot of them do, but I always like to have a backup for these kids who might finish early, and give them something to challenge them that's still within our topic. So then I would give them this open middle problem. If you're not aware of an open middle problem, I highly recommend you go to openmiddle.com, check them out. These are awesome for challenges. They're also awesome to do on the whiteboards. And they're great for just checking to see if the kids really understand what they're doing. So I highly recommend open middle problems. Kids really like the challenge. All right, and then, you know, I already kind of talked about open middle problems, but here you go. So here's some more examples of open middle problems. Sometimes this is just going to be my whole lesson, is I'm doing an open middle problem. Sometimes it's my way to challenge them a little bit more, but I always have an open middle problem ready to go, no matter what it is we're doing. And they have open middle problems from kindergarten to college level classes. They're just all over the place, and they're really awesome. All right, so what I just talked about, the tasks, the whiteboards, the random grouping, those are in year one. Those are the 3 things that you really need to do to be a thinking classroom. But there's a lot of other little things. There's 14 total, really. And so I'm just going to quickly talk about them, because I am watching time here, but I'm going to quickly talk about them and some of the things that I've been trying. Like I said, I'm not an expert, and I'm not great at all 14. I am still learning and going. And one of the places that I'm learning is this book that came out. Peter finally published this book. I've been waiting forever. This book is awesome. And I am learning so much, and I'm trying so much in my classes right now, even with COVID regulations. I'm still doing what I can with them. One of the things that he talks about is using verbal instructions. Instead of putting things up on the board, tell them. If you're going to tell them about the rats eating cats, or no, the other way around, the cats eating rats kind of stuff, then, you know, don't write it down, say it. Now, sometimes you actually have to have, like, if there's an equation they need, or if there's data they need, you need to have that on the board, but don't put a bunch of words. It takes too much for the kids to read through the words and translate it all and figure it all out. So tell it verbally, and then they'll go to work faster, and they'll better understand. They're not going to waste their time translating. Defront the classroom. So, you know, I never realized I defronted my classroom, but I have boards all around. I still have a smart board in the front that I use to, you know, present things. I have a teacher desk. I got rid of my teacher desk now with COVID because I wanted to make room in my room for, you know, students to spread out. But I didn't realize that I did not have a front of the room. This is pre-COVID. I said to the kids, okay, you guys, I got to do something, but I need to meet you at the front of the room. And they didn't know where to go. It was really quite cool that they didn't know where to go. And I realized it's because I've been using my whiteboards all around the room. If I'm going to present something, I might walk back there. I might walk over there. I might use whatever board. And so they really are kind of kept on their toes, not knowing where the front is. So defront your classroom. One thing that's really difficult is answer only, keep thinking questions. I'm not going to get into detail here, but, you know, he talks about 3 kinds of questions. And if it's just to answer like like I always tell them, I'm not your calculator, don't ask me that question. If it's going to stop them from thinking like, am I right questions, I'm not going to answer that. I'm going to ask them, do you think you're right? Can you prove it to me? Can you prove it to yourself? Maybe you just need to trust yourself and go forward, but stop answering all their questions. Stop being the thing that just stops them thinking. Only the ones that keep moving them forward do you answer. Mindful notes, I'll talk about those at the end. So I don't write notes on the board and expect the kids to copy them. The kids make up their own notes. Building autonomy. I didn't totally understand this until I read it in the book, but you know, Peter talks about getting these kids to stop having to ask the teacher for help, for questions, things like that. So when a kid asks you, okay, what's my next problem? We're done. If they can look at another board and get their next problem, that's going to help you out as a teacher because you're not always having to give them the next problem. So I might be, let's say I'm over here at this board and they're like, I give them the next problem, right? And then I go over to a board over there and they said, okay, we're done. I say, okay, look over at board ACE to see what your next problem is. Or maybe I'm at this board over here and they're stuck and I know that board ACE had a good idea. I'm like, hey, you should look around the room. Go look and see what some other groups have done. And by doing that, instead of answering the questions, by directing them to look at other boards, you are now giving them the autonomy to do that. Now, you could tell them all the time, I encourage you guys, you know, if you're stuck, look around the room, but without actually doing it in the moment and saying, go look at them, they actually are not going to take that opportunity. And now I've started doing that the last couple of weeks, and I'm seeing that my students are doing it on their own rather than me having to tell them. So you have to be very, very, I can't think of the word, but you have to really direct them to do it. Purposeful. You have to be very purposeful about telling them to do it, and then they're going to. Year 3, so I'm, you know, just getting here, but using hints and extensions to manage flow. Level to the bottom, what he's talking about, you know, like the 5 practices talk about doing consolidation at the end of a task. And what he's saying is don't consolidate to the extreme of what you wanted them to get to, consolidate to the minimum of what you needed or the minimum of where the last group got to. So if you have a group that's like not quite there, just consolidate to that point where everybody can be together and understand. Okay, you do not have to do the max and the finale. Okay. And then assign, check your understanding questions. I am still kind of resistant, you guys. I've been 18 years of giving homework and grading homework, and I'm trying still to wrap my brain around and let go of my trust issues here about not giving homework and just telling them, hey, here's some problems. If you want to practice, you can use them, because like I'm having a hard time believing that they're going to use them. But I'm getting sold. Like I'm drinking the juice here. I'm reading the book, and you know, I think I'm almost there. I need to try it though soon. I might try it 4th quarter with one of my groups just to kind of test the waters. But anyway, so the idea is not to give homework, but just to give problems and say, hey, you should practice these. These are yours. I'm never going to look at them. I'm never going to ask for them. I'm not going to check to see if you did them. This is you. You do you, and be responsible for your own learning. kind of uncomfortable, right? I'm still even saying that out loud. But I'm going to get there. Okay. Year 4. So this is kind of like the people who have been doing this a long time. And this is where I really need to learn more about, but communicate where a student is and where they're going, evaluate what you value, and report out based on data. And I haven't gotten that part of the book. I haven't been lucky enough to go to a workshop where Peter's presenting. So I haven't had anywhere that can tell me this other than the book coming out. I just haven't had the time in this COVID year to be able to read it all yet. So I'm super excited to learn about this and hopefully start implementing this more in my classroom next year. So here's a sketch note of all the things I just talked about. I like this sketch note because I feel like it explains a little bit more of all these things. So you're going to see in this top line is year 1. So this is the 3 things that you must do. And I like that it kind of goes into more detail, right? Year 2 are these 4 or 5 things that you should be working on. And what does it all mean? Year 3, and then year 4. So, go back to this, check it out. What I did is I just typed in Building Thinking Classroom sketch note on Google, and this came up. And I've printed it off. I have it on my wall. I actually, really quite interestingly, had it on my wall before I heard about the Thinking Classroom. This just came up one day and I was like, this looks really good for using whiteboards. I'm going to check it out. I have a tip over here on the right. This comes from Necessary Conditions from Jeff Kroll. That he says, if kids are stuck, before you start answering, just ask them, if you knew what to do right now, what would it be? And he's found that kids actually have an idea what to do. They're just not confident enough to try it. So ask them that and see what they have an idea to do, because it might be something worth investigating. Okay, I want to take what time I have left to share some lessons. This exponent lesson is like my favorite lesson of all time. And if I can get all my parents to give me permission, I just videotaped it and I would love to share it with you. Now, if I can give that all the permission, you're going to see a link on one of these pages so that you can watch the video. But I want to give you a little warning. It is during these COVID times. One of the challenges with this COVID times is to keep the kids, spaced. So I have X's on my floor so that they're 6 feet apart. Another thing is, of course, having the kids wear their mask over their nose. You're going to see it's not always perfect in my classroom. I apologize for that. I work really hard at it. This day in particular was difficult for me because I was carrying around a video camera with me and worrying a lot about what I was doing. And I even have a girl eating a sucker, which drives me nuts because it's not something, especially right now where you're supposed to be wearing a mask, that I would allow. And I did not even register that she was eating a sucker until I watched the video. And oh, I was so mad that it happened, but please forgive me. I'm human. But we're all working to try and keep these kids safe. And it is important to me that they are spaced out. I did give the kids permission though, that if they have something to point out or they have something to write, that if they get within 6 feet for a minute, it's okay. We just want to try and stay 6 feet at most times. So hopefully I can get that video out to you and you have a link here to look at it. But here's the exponent lesson. I'm trying to teach about negative exponents and 0. Those 2 things that kids just always struggle with. So what I do is I give them this visual pattern and I ask them to do a notice wonder on it first. And, they really notice a lot of things. They notice that this is number-based 3. They notice that they can copy the pattern onto the next one. Let me see if I can get my annotate tool here. So they see that, here's the 9 and they can put the 9 here, here, and here. So, it's a triple. And then they can see that they have this 27 and that 27 happens 3 times. So they realize that they're multiplying by 3 all the time. There's all kinds of things that they notice. They notice that it goes rectangle, square, rectangle, square. And so then I start asking more questions like, so I do this notice wonder. A lot of times I start with a notice wonder just to get the kids in it. And then I put them at the boards and I say, okay, I'm going to give you a different one. So I'd give one group based on 2, another group based on 3, 4, and 5, so that around the room we have different things going on. And then I ask them, what does the 5th one look like? What does the 6th one look like? And then after that, I'm like, what does the 10th one look like? How many squares would there be? Could you draw it without having to draw the ones in between? I don't have them draw the little squares, by the way. I encourage them to draw more efficiently and maybe take notes a different way instead of drawing squares. And then I ask them, what patterns do you see? And then after we've discussed it and they've told me things, we talk about how that 3 at the top is the first one, and then it's the second one, and it's the third one. And so then I say, what would the 0th one look like? And so they start figuring out how could they go backwards with their pattern, and they come up with this 1 square. And then I ask them, what would the negative first one look like? And what would the negative second one look like? So they're working on those things. They have a bunch of misconceptions that we have to work through. It's wonderful conversation. And then my next thing is, can you make a table out of it, out of this data? Can you collect all of this on a table? And then can you write it using exponents? So can you add another column to your table that is exponents? Can you write it using exponents? And so at the end, we consolidate. So you see it says consolidating there. So the idea of consolidate is, this is just like the 5 practices, you guys. So like, that's one of the things I love about Thinking Classroom. It's not new. It's not saying, okay, ignore everything else that's wonderful and we know is great and just do this. No, this just gives you a way to incorporate all those things. So we consolidate, and I walk around the room and I look at the tables and I say, what do we notice? And we talk about the 0th power, and we go to each table and we see that no matter what their base number was, the 0th power always gave them 1. And why? And they tell me why. This is what's so cool. They tell me why it's 1. Now, I'm not saying this fixes it. So fast forward a week. I'm at a week right now. Okay. And I tell them, okay, I have 11 to the 0 power. And do you know how many of them tell me it's 0? A bunch. And I say, wait, no, let's go back to our blocks. And so we draw a thing of 11, and I ask them, what is it when we go back 1? How are we going back 1? They're like, well, you're going to divide by 11. You're going to split it up in 11. You're going to take one of them. So what is 11 to the 0 power? 1. So they fix their mistake, even though they make it right away, because they're not thinking, you know, they're just jumping out with answers. So they fix their mistake. They know how to logic through it. They can figure it out for themselves. And then we look at the tables and we go around the tables and we notice the negatives and what do all the negatives look like and how can we make connections? And we make those connections that 3 to the third, and 3 to the negative third have the same number, just in a different spot. Where is it? What are we doing? And they come up with it themselves. It's a beautiful lesson. I love it. It's really fun to go through with the kids. Okay. It's not going forward now. All right. Okay, so that's what the paper looks like. Here are my questions again. I have a unit circle lesson. Looking at my time, I don't have a lot of it. I have a unit circle lesson. Again, you have access to this. You can read through it. This has been wonderful for my trigonometry class to understand how we get these numbers here. So they can figure this out for themselves. I don't tell them, and it's just a beautiful lesson too, to go through and let the kids explore, because the more they explore, the more they're going to understand it, right? They say whoever's doing the talking is doing the thinking. Well, my kids are talking. I'm just walking around listening. A lot of times I get bored, actually, and I have to just jump in and challenge myself to ask them good, challenging questions that, number 1, am I understanding what they're thinking? And number 2, am I expanding their thinking? Okay, so let's talk about norms at the boards. I often, most of the time, tell my kids 1 marker per group. I've already gone through this with you, right? If you want something written, then you hand the marker over and you tell that person what to write so that we keep everybody involved. The other thing that I work really hard at the beginning is that everyone has something to offer. I try to make sure that that kid who has come through the ranks and everybody thinks is a dumb kid, I make sure that they have something to offer and that everybody sees the value in that person. And that's on me to make sure that other kids see it. And then to make sure that kid sees it and gains some confidence in what they're doing. And then the other thing is everybody in the group needs to understand before moving on. So I'm going to come to the group and I'm going to ask a random person what's going on. If they can't answer me, I tell the group, you know what, I'm going to be back. You guys need to make sure everybody understands. And then I come back and they've done that. Okay. Now, what about me? What is my job during this time? There's so many times I've stood here like, okay, I'm bored. What do I do? So what do I do? First off, before I do one, I need to make sure I know, where is this problem going? What do I want the kids to get out of it? And how can I make sure they're going to get there? And then what do I expect the kids to do? So again, 5 practices. What do I expect the kids to do so that I know how to progress them? So I know how to check for their misunderstandings and do all my teacher moves. The other thing is really important to me is I'm only asking questions. When I join a group, don't talk. One of my first things to do is ask what is going on. So I will look at something, especially if I see a mistake, or even if I don't, and I'm just like, do they really understand what they did? I'm going to say, wait, why did you write x squared here? What were you doing? Okay, explain to me how that works. So I ask a lot of assessing questions. It's interesting what comes out of them. I learn a lot about these kids when I ask, and a lot of times my assumption was wrong. So just note that. My assumption is usually wrong on what these kids understand by looking at their work, which makes me question my grading on tests sometimes too. And then once they've answered that, now I can start asking advancing questions. How, now that I know what they think and what's going on, how can I push them forward? Now, I want to say something. Here's one of the coolest things about this, that what happens here. I walk around the room and I talk to every group. Now, here's what did not happen before when I lectured at the front of the room. When the hour's done, I can confidently say that I have talked to every kid in my class. I could not say that before. Before I could say I've talked to like 3 kids because it's the ones who raise their hands and I call on them, right? But I could not say that before. I can confidently say I talked to every kid in my class. And I now have a whole lot more knowledge about what every kid can do. I know where my kids are at all times. I have talked to them. They have told me what they know. I mean, like, really, do I need to hand out a quiz anymore? I don't think so, because I know where they're at, right? And so this is where I need to get more into my assessment and reading the book and understanding how can I do my assessments differently now. And then here's the hard part, walk away. I need to walk away when I know that they can move forward. So if I've asked them a question or they've asked me a question and I'm asking them questions, progress, and they ask something or they say something and I'm like, okay, I'm confident that they can now problem solve. I've pushed them just enough that they can get going. I walk away. Now, at first the kids are like, hey, where are you going? But they're learning now that if I walk away, they know that I have confidence in them to move forward. Also, like if they ask a question that is not a keep thinking question and it's something they can answer themselves, or I know they're just trying to get me to like confirm them, you know, the best thing you can do is smile and walk away. And they're going to learn that if you smile and walk away, you have confidence in them and they can do it, and they'll stop asking those questions too. And then the other thing I need to do is I'm paying attention to what it is they're doing, because when I consolidate, I want to go to their boards and I want to use their boards to consolidate. So I'm looking at, number one, which group am I going to use and what order am I going to use them? And sometimes you have to go up to the board and circle something and say, do not erase this. I need this later. So please keep this. So, you know, that's another thing that you're doing. Or if you really want your consolidation to include something that none of the groups are doing, you can join a group and like challenge them to try it this way. Principles to actions and then the 5 practices. These are huge books. These are things that I recommend no matter what you're doing. You need to do these. I've learned so much from them and they've taught me so much. So when you're consolidating at the end of a task, see the 5 practices. I'm not going to talk about that right here. 5 practices covers it. If you don't have the book, get it. If you can't afford the book, email me, I'll send you it, okay? Meaningful notes. This is something that's different that I did not do before, but I do now. So meaningful notes, where what's happening is after a kid has learned it, they reflect on what is it they learned and what's important about it. So one of my favorite things that Peter has talked about is you tell the kids, what does your future forgetful self need to know about this? A month from now, if you have forgotten how to do it and you need to do it, you want to be able to look at your notes and it tells you what you need to know. So what is it you think your future forgetful self needs to know? And then they are writing in it. Okay, it's not done during the activity. You know, so many times I used to teach that I would say, write this down and now we're going to practice it. That's the activity. It is done after the activity. Okay, and at the beginning of the year, you model. Okay, so I model, I show them what I would write at the first, and then I encourage them on the next time they're going to write it, and then they go and check each other's out and what could they add to it. And then I might model it again to show them. And I spend a lot of time modeling what they should do. And this is what they look like. It's super easy to make, okay? You just make boxes of the key things you want them to take notes on, and you leave it open. You just give it a title, and then they write on the notes. It's super easy. I made them really quickly. This is my one on exponent rules. So I would spend a day on maybe 2 of the exponent rules at the boards. And then I would tell them at the end, go find them in your red book. I call them a red book because I make a cover for them and I give them all the whole years in one, binded together. And I say, go find it. And what do you need to write down? What could you write down for yourself? So it's really interesting to see what they come up with. But this is for them. This is not for you. So these are some examples of what the kids write down. Some of them let me take some pictures. Since you're videotaping, I'm going to keep going, but you can pause it if you want to take a longer look at them. This is in my Algebra 2 class and the things that they found important to write down and help themselves. And this year, being a COVID year, I've been letting them use them on tests. 1, because my kids at home, I don't know if they have them out anyway. And 2, why not? They made them for a reason, right? So I'm letting them use them. Okay, so a lot of times people wonder, what does a full class look like? So what does it look like from beginning to end? So you start your intro, whatever that may be. I do a lot of notice wonder. You get on the boards. So that middle one where it says managing flow, it's the boards. So managing flow is something that you can look at for a chapter, but how do you get them challenged, moving them forward, letting them struggle, all that stuff. Then we consolidate. So I go around, we talk about it. I use their work to talk about. After we consolidate, they go to their meaningful notes, write it down. There's a lot of teachers that the meaningful notes is the homework. So they consolidate, the bell rings, their homework is to write down meaningful notes for the day. And then they give them check understanding questions. You'll notice there's no class time. There's no class time for that because those are supposed to be on their own. It's not assigned or graded. So it's just, here are some problems for you to check out. These are good ones that if you can do them, then you know you're good. If you can't do them, then you know you need some more help and some work on it. One of the things that you can do using either for tasks or your check for questioning or purposeful practice, the idea is that they have a reason for doing it. So like add them up, which I learned from Sarah Vanderwerf, is you give them, 3 problems, 4 problems, however many people in the group, everybody gets a problem and their answers should add up to a certain thing. If they don't add up to that, then they know they made a mistake, but they don't know where. So they all as a group have to figure it out. There's a lot of enriched stuff. Just look at these and you can see what purposeful practice. So it's not just doing the worksheet to get the worksheet done, doing the problem to get the problem done. Like the answer to the problem has a purpose to it that you're going to then use it for something. So open middle is another one where you're like, find the biggest answer. So they do the problem and they're like, oh, is it the biggest? I don't know. Let me try and tweak this and then get a bigger answer. So there's this purpose to why they're doing that problem. I have more examples, but I really don't think I have much time left. This is a fun one that I came up with because we were doing systems of equations and I wanted to do a word problem that wasn't about apples and oranges. So I came up with this one about how many calories is this cookie that they notice here. And so I let them struggle for a while. So if you've heard Dan Meyer talk about create the headache so that your math can be the aspirin, that's what I do. I create the headache. And then, I give them information about a regular bag of cookies and you can see the calories there and a double stuff. And we talk about how many calories is this big cookie and they figure it out for me. Another one where I talk about explicit and recursive and I give each group a different problem so that when we consolidate, we're talking about all kinds of different problems and get different things. So then here's a notice wonder that we did with explicit. I love how much they notice and how much we can talk about based on their curiosity. And this is another one in my sequences and series, just some problems. So here's my tasks, like what's your allowance going to be for the year if you did this one? And what would the equation be? Can you use the geometric formula to do that? Over here, this is a piece of paper. And if I colored half of it blue, and then I colored the remaining half blue and the remaining half blue and the remaining half blue, the question is, will ever the whole piece of paper be colored? And then is 0.9 repeating equal to 1? Asking them those questions. So they have to problem solve and use the skills that they've learned or ask for them, create the headache so that they ask for the aspirin. Okay, where can you find other problems? There's so many places. These are some that I would highly recommend, all kinds of places to do it. One of the things that you can do, like if you're trying to find a good task, you could just go into your textbook and take a task and take away a bunch of the outward stuff and just ask them a very bare question, a bare thing without all the scaffolding that your textbook does. Or sometimes I just say, hey, we need to do problems 1 through 12 on the board, and they go work on them. They don't need me. They work together in groups, and it's just, they do so much more thinking than they do otherwise. Or if you have to teach something that's dry, maybe have them try it before you even teach it and see if they can discover the math on their own. It really creates a lot of confidence in these guys. But here's something I have to remind myself, and I have to remind myself this. It's unreasonable to ask a professional to change much more than 10% a year. That's me. I try to change like 50% a year and I get overworked over the summer and I need to relax, okay? But I want to challenge you also that if you haven't changed 10% in a year, are you doing enough? Okay, so I've been teaching for 18 years and I've taught 18 different years. Some people teach for 18 years and teach the same year 18 times. So I challenge you, be the first, be the one who teaches 18 different years. Try something new. It's a lot of fun doing this. Some other resources here. I have a bunch of links for you. Buy this book. Seriously, this is the best book ever. I just haven't had the time to finish it, but I'm studying it and trying things before I go on to the next chapter. And then also the Make Math Moments Matter podcast. Love it. And they interviewed Peter twice. Lots of really great stuff from him in there. And then Necessary Conditions. I think there's so much that you can take from here. Plus you have the 5 practices and all that stuff from MCTM. Okay. Whew, I don't know. I don't know what time I'm at, if I'm at an hour or over an hour, but here it is again. Here's the bit.ly again. If you would like to be able to access this for all those links that I put in there. Hopefully I have a video in there by the time you watch this too, so that you can see a class in action. Again, forgive me for my errors in the video, but it's just fun to hear the kids and see them learn. I thank you so much for joining me. I'm going to do a live session. I'm going to call it Thinking Classroom 2.0, where we talk about maybe year 2 and year 3 and what is it that I've learned since I started doing this. And, you know, what have I been growing this year, and maybe answering some questions for people who have been trying this. We can problem solve together. I want it to be live so that I can interact with you and I can answer questions. Some of you out there maybe have things you can answer. I'm not going to claim to be an expert by any means. I just love sharing this with everybody. So thank you for joining me, everybody. I hope you're enjoying your time here and that you're enjoying our virtual workshop here, our virtual conference. It's been a lot of work. Please make sure you thank the people that you know that are involved, because they've been doing a lot of background work for months. All right, I'll see you guys later. I hope you have a relaxing summer, and next year we can start and you can jump in with the Thinking Classroom. All right, thanks everybody.